Okay, let's talk about the different types of organic reactions. And they use some slightly different names than you would have learned in earlier chemistry courses. One type of organic reaction is called an addition reaction. And as the name is implying, two things are going to be added together to make one product. For this to happen, I usually need some sort of multiple bonds got to be present here. Yes, they need to be broken. Needs to be broken, and that'll allow stuff to add in. So, for example, I could do C with H8. So this is ethene. I could add in hydrobromic acid, and I could get Br. And where I put the Br doesn't matter. I'm getting only one product all the same. A substitution reaction is where one atom comes out and another atom goes in. So, for example, I could have some sort of methane. No, let's do Cl here. And I could react it with F2, and fluorine is more reactive than chlorine, so fluorine can bump chlorine out, and I could get, it's a bad example, if I may. I'm going to not use that one, I'm going to use HF. And then I would get HCl being spit out. So Cl is coming out, F's going in. Elimination reactions where atoms are going to be removed from a molecule. So you can say that this is the opposite of addition. Yes. So, for example, I could have something like this. I don't know, it's called Cl, and under the correct conditions, and there's all sorts of things you can do to make this happen, I can suck out the Cl, and I could suck out an H, and I could be left with this plus HCl. And it's all about the conditions that you're going to put this molecule under to get it to make the things that you want. Condensation reaction is when water is going to be removed from a molecule or molecules. Now, we did a lab where we were like this with COOH, yes, and you can get water to come out of this thing, C double bond O, C double bond O, up to there. I could just get water to come out of this one molecule, or I could get water to come out of a reaction between two different molecules. So, for example, I could have methanoic acid, and I could react that with methanol, which is right there. Yes. And I could get, do some circling here, this guy can come off, and that guy can come off, and I can make some water. And then what's left over also has to stick together. So I get the C double bond O, and I would get this as my other product. But again, water's coming out. Anytime water's coming out, you get a condensation reaction. Hydrolysis reaction is when water is added in. So I'm not even going to do an example, but it would just be the opposite of this. I could write this arrow giving this, or write this arrow giving this. Opposite of condensation. Combustion reactions. There's two types of combustion. This hasn't changed from your earlier chemistry courses. Complete combustion is when I have all sorts of oxygen available. So CH4 plus O2, and in complete combustion there's two types of products, CO2 and H2O. And I can balance it. I don't really care that much about balancing here. If it's incomplete combustion, I don't have enough oxygen being supplied, and I start to get other things made. I'm going to get my CO2, I'm going to get some water, but I also are going to get some carbon solid, soot, the black stuff, charcoal. And I might also get some carbon monoxide, which causes a big health concern in your home if you're not careful and something goes wrong in your furnace. If this stuff starts getting made, this stuff can kill you. You can't smell it. It attaches to hemoglobin in your blood, red blood cells, much better than O2. This stuff is bad news. Finally, we've got oxidation and reduction reactions. Oxidation is when you make more bonds to O or less to H, and reductions, you're making more bonds to H or less to O. So let me give you an example here. Here is an alcohol. Yes. Currently, it's this carbon right here, this guy right here, is making one bond to an oxygen, and it's right there, one. This is any oxidizing agent. I'm not interested in specific ones. There's all sorts of things that oxidize. We'll just use the general term O with a square bracket around it. So currently making one bond to O. More than one would be two. So one possible product here would be, instead of making just one bond to O, would be to make two bonds to O. And then I would have an H. Yes? So we're going from one bond to O to two bonds to O. I could continue to oxidize this. What's bigger than two bonds to O? Three bonds to O. So I could get C, double bonding to an O, and then bonding to another O and an H. Yes. So I can actually oxidize an alcohol all the way down to a carboxylic acid. Each step is an oxidation, and I'm making more bonds to O. And at the same time, I'm making less to H. Currently, two bonds to H. This carbon's making two bonds to H. Now it's making only one. Now it's making none. Now, an example of a reduction reaction, and I'll do one, would be, here is a ketone. I am going to hit it with a reducing agent, and we'll use this as our symbol for any reducing agent. Currently, this carbon is making no bonds to H and two bonds to O. So if I draw the shell again, these guys aren't necessarily going to change. I'm going to make less bonds to O. Currently there's two. Less would be one. Yes. So I can reduce that down to an alcohol. I'm also going to need another H. So recapping, two bonds to O, now one bond to O. No bonds to H's anywhere here, one bond to H here. And I can continue doing this. Whoops. Let me put in my symbol for a reducing agent. Yes. And I'm going to pick this. And if currently there's one bond to O, less than one would be 0. So I can reduce this all the way down to propane. So these are the different classes of organic molecules. We can add things in, we can substitute, we can get rid of things. Water's a big thing because functional groups, a bunch of them have, organic functional groups have OH groups, and so they like to undergo condensation reactions. I can add water in, I can burn stuff, or I can oxidize and reduce. And these are really, for those of you who know, these are really simple definitions of an oxidation or reduction reaction. There is a much better definition of an oxidation and reduction reaction that we will learn in the last